Find the y-intercept, if any, x-intercepts, if any, vertical asymptotes, if any, including the asymptotic behavior on each side, and holes, if any, for f of x equals x cubed plus x squared minus 2x divided by x squared plus 2x minus 3. The first thing to find is the y-intercept where the function crosses the y-axis, defined by x equals 0. The corresponding y-coordinate can be found by plugging the 0 in for x into the function f of 0, which will give 0 cubed plus 0 squared minus 2 times 0 divided by 0 squared plus 2 times 0 minus 3. 0 cubed is 0 plus 0 squared is 0 minus 2 times 0 is minus 0 divided by 0 squared is 0 plus 2 times 0 is 0 minus 3. 0 plus 0 minus 0 is 0. 0 plus 0 minus 3 is a negative 3. 0 divided by any non-zero number equals to 0. The x-coordinate was 0. The corresponding y-coordinate was found to be 0. And so the y-intercept will be 0, 0, the origin. The next parts are all found by taking the function f of x, which is x cubed plus x squared minus 2x divided by x squared plus 2x minus 3, and fully factoring the numerator and denominator. The numerator has a common factor of x. Factoring that out, we'll leave x squared plus x minus 2. The denominator is a trinomial quadratic, which will factor into x and x, two numbers that multiply to be a negative 3 and add to be a positive 2. That'll be a positive 3 and a negative 1. In the numerator, we also have a trinomial quadratic left over after the x had factored out. Two numbers that multiply to be a negative 2 and add to be a positive 1. That will be a positive 2 and a negative 1. And then we can cancel out any like factors, leaving x times x plus 2 divided by x plus 3. The x-intercepts, where the function crosses the x-axis, defined by y equals 0, can be found by taking the numerator that's left over in the fully factored canceled version of the function and setting it equal to 0. X times x plus 2 equals 0. That means x could be a 0 and x plus 2 can be a 0. X equals 0 means the x-coordinate is 0. It's corresponding to the y-coordinate 0 already established. And then x plus 2 equals 0. We can subtract 2 from both sides, and x will be a negative 2. So the x-coordinate's a negative 2. The y-coordinate's a 0, again already established. For the x-intercept, y is always a 0. There's the two x-intercepts. The vertical asymptotes are found by taking the remaining denominator expression and setting it equal to 0 and solving for x. So that comes out to a negative 3. We can now analyze the asymptotic behavior on both sides of the negative 3 by the left-sided limit, and this is always done on the fully factored canceled version of the function. And the right-sided limit, also on the fully factored canceled version of the function. Let's start with the left-sided limit. We want to look at the factor in the denominator that is making 0 in the denominator as x approaches negative 3. Well, that will be x plus 3. Now we're approaching negative 3 from the left side, which means more negative than negative 3, like negative 3.01. If that were plugged into x for the x plus 3 factor, that will give negative 3.01 plus 3, which will equal a negative number. It's going to approach 0, but it will remain negative, so we can now replace x plus 3 with a negative 0. Negative 3 can plug in for all remaining x's, giving a negative 3 times a negative 3 plus 2. The x plus 3 is going to be a negative 0, since x is approaching negative 3 from the negative side, giving a negative number, but approaching 0. In the numerator, negative 3 times negative 3 plus 2 is a negative 1 over negative 0. Negative 3 times negative 1 is a positive 3 divided by a negative 0. Positive over negative is negative. Non-zero over 0 is an infinity. We can analyze the right side of the limit in a similar fashion, but it's the right side of negative 3, which is less negative than negative 3, like negative 2.99. If that were plugged in for the x and the factor that's making 0 in the denominator, negative 2.99 plus 3 is a positive number, but it's approaching 0, so we can replace x plus 3 with a positive 0. Negative 3 can plug in for all other x's. So negative 3 times negative 3 plus 2 divided by what will be a positive 0, since x is approaching negative 3 from the right side, making a positive number for the x plus 3 factor. In the numerator, it will be negative 3 times negative 3 plus 2, which is a negative 1, divided by a positive 0. Negative 3 times a negative 1 is a positive 3 over the positive 0. Positive over positive is positive. Non-zero over 0 is an infinity. And there's the asymptotic behavior on both sides of the x equals negative 3 vertical asymptote. The last thing to find is any holes in the graph, and those are determined by the factored version of the function and the factors that cancel so that they fully cancel out of the denominator. X minus 1 did cancel, and it fully canceled with every version of itself in the denominator. There was only one of them down there, and it did fully cancel out. That factor, if set equal to 0, will give the x-coordinate of the whole. We can find the corresponding y-coordinate by plugging that x-coordinate in to the fully factored cancel version of the function, which will give 1 times 1 plus 2 divided by 1 plus 3, which will be 1 times 1 plus 2 is a 3 over 1 plus 3, which is a 4. 1 times 3 is a 3 over a 4. And there's the corresponding y-coordinate. So the x-coordinate is a 1, the corresponding y-coordinate is a 3/4, and there will be a hole in the graph at the point 1, 3/4.